So since they both equal 9, when we take the square root of 9, we get both of those, okay? So we'll practice that more, but just remember whenever there's an even one, you're going to get 2 solutions. So this is what you learned how to do last year, okay? We're just doing the inverses of exponents, which you already know what those are. Those are radicals. So looking over here, we have an x squared. We need to get rid of that, but the first thing we need to do is to make sure whatever the value is with the exponent is alone. It is not alone on this side of the equation. So what do we need to do? Add 4. Opposite of subtracting 4 is adding 4, so those will cancel out, and you're going to have x squared equals 25. Now x is alone, so how do we get rid of something squared? We square root it. So x equals 5. Does it only equal 5? No, because when we square something, 5 squared equals 25, and negative 5 squared equals 25. So our other solution is negative 5. Okay? So that's what this part was talking about, is inverses. Just like how when I have 3 and I add 2, I get 5. To go backwards, the opposite of adding is subtracting 2, and I'd get to 3. Same with multiplying. If I had 3 and I times by 2, I'd get 6. Opposite of timesing is dividing by 2. So if I had 4 and I squared it, so 4 squared, I'd get 16. To undo that, I'd need to take the square root. What if I had 2 and I cubed it? I'd get 8. Well, what's the opposite of cubing something? Taking the cube root, okay? So those are inverses, they're opposite each other. So if I take the cube root of 8, I'd get 2 again, okay? And you can use your calculator on a lot of these. So let's go over here. So solving radicals in radical form, steps. So this one's in radical form. So like we're just going to go the opposite. So the opposite of cube root is cubing it. So steps is get the radical alone. I am not spelling alone. There we go. Okay, get the radical alone. So if we look right here, on this side of the equation, is the radical alone? No, so we need to add 9. So I have cube root of x equals positive 3. Now, we need to do the inverse. So take the inverse of both sides. Take the inverse of the radical and do it to both sides. So the inverse of a cube root is cubing it. Okay, so what do I get? X equals 27. 3 times 3 times 3 is 27, okay? Now, the last step is, if you had something like this inside your radical, x minus 2 equals 3, and you cubed it, you'd be left with x minus 2 equals 27. Is x alone on that side? No, so you'd have to finish solving. So that's the last step, is just finish solving for x. So that means we would have to add 2 to both sides. That's just if there was something other than the x in the radical. We still got the whole radical alone though. There's just something else in it. Okay, so let's practice. Ideally, I'd like to pause the video and have you guys practice this. Practice question, honestly, 2, 3, 4, and 5 to see if you can do it. So if you can pause it, that'd be great. I'll go through it right now so you can unpause it to check your answers. I'm not going to go through 6 and 7. That's something we can talk about next class because they're harder. And I want you to try these harder ones on your own. Okay? So that's why I have those circled. They're just more challenging, which I always want to give you guys a little bit of challenge. Push yourselves to think a little bit more. We'll talk about why they're a little bit harder in a second. But let's look at question 2. Is the radical alone on that side? No, it is definitely not. So, question is, what do we get rid of first, the 2 or the 3? Well, when we're solving, we have to do the opposite of our order of operations. So we actually have to get rid of what's furthest away from x. So that's going to be our 3. So we need to minus 3 to both sides. So we get 4. Now we can get rid of the 2 by dividing both sides by 2 to get that radical alone. Okay, opposite of a 4th root is an exponent to the 4. So I'm left with x equals 2 times 2 times 2 times 2, which is just 16. Okay, so that's our answer. So it's not too hard. Let's look at question 3. Is the radical alone on this side? Yes, it is. Raise it to the exponent. So those cancel out. We're going to have 5x plus 1 equals 2 to the 3, which is 8. Now we still need to solve for x. Minus 1. So I'm going to have 5x equals 7. Still need to solve for x. Divide both sides by 5. So x equals 7 over 5. Go to the next one. Minus 1, minus 1, because we need the radical alone. This is the radical right here. It is not alone. So we're going to have 3 x minus 2 underneath the square root equals negative 12. Then we need to divide by 3. We're left with the square root of x minus 2 equals negative 4. Okay, now if we square it, what happens when we square a negative? Well, it actually becomes positive. So you have x minus 2 equals 16. Then add 2, x equals 18. Okay. At any time you can pause it, rewind it, check your work. Let's go to this next one. Again, this is the radical. It needs to be alone, so let's minus 5. So we get 8. Then we're going to divide by negative 2. So we get negative 4. So now we need to have negative 4 to the exponent of 5. So negative 4 to the exponent of 5. What happens when we have an odd and a negative? Well, it ends up still being negative. So we have 3x minus 1 equals negative 1024. Okay, now we can add 1. So we're going to have 3x equals negative 123. And we're going to divide that by 3. So it's negative 341 is what x equals. Okay? These ones, why is this a little bit harder? Well, there's 2 aspects to it. We have an exponent, and we have a radical with an index. Well, what's the opposite of an exponent? Well, that's a radical. So in order to get rid of this exponent that's on the outside, because remember we're always working outside in. So to get rid of the exponent, what's the opposite of an exponent? A radical. So we actually need to take the cube root on both sides to get rid of that first. Then we can square whatever we have left. Okay? So that's the process. That's what's going to be a little bit harder. So you have to get rid of the outside first. So, like I said, we're going to have to take the cube root. So let's just do that. I'll help you with the first step. So we're going to end up with square root of 2x plus 3 equals, and then whatever the cube root of negative 8 is, which is negative 2. So now we can square it and keep solving from there. It's going to be the same thing with 7. And if you look down here, that's actually going to be a similar thing with 12 and 13. Okay? So remember our fraction exponents here. Remember, that is like a square root because it's on the bottom. It's like we have square root raised to the 3. And this one is like I have a cube root raised to the square. Okay? So these are a little bit more challenging. I want you to try to do them. Okay? Let's look at the steps for the opposite. So when we start with a fraction exponent, okay? So again, let's isolate it. Let's isolate our radical. Even though it's in exponent form, let's isolate it. So in order to do that, we need to add 9 to both sides. So you have x to the 1 over 3 equals 3. Now remember, this is just like I have the cube root of 3. Okay? So in order to get rid of that exponent, if I raise this to the 3, well, remember our exponent properties? We multiply the exponents. So that's just 3 over 3. What's 3 over 3? 1. So that's how we cancel it out. Okay? So we're just multiplying it by its reciprocal. So multiply the exponent by reciprocal. The only thing is when we have these where it's 3 over 2, it's just a lot easier to do step at a time. So get rid of the 2 and then get rid of the 3. It might make it a little bit simpler for you. But here, since we only have one number we really need to get rid of, we'll do that. So we'll put 3 on both sides. We're going to have x equals 3 to the 3, which again, x is 3 to the, not 3, is 27. So last step again is finish solving for x if you need to. So let's look here. If we times both of these by 5, because it's isolated and alone, we're going to have 7x equals 1 to the 5, which is just 1, because those are going to cancel out. Then divide by 7, finish solving, so x equals 1 over 7. Okay. Let's move over here. So, is it alone? Is the radical alone? No. I mean to minus 2. Remember, it's the 3x's raised to the 1/2 equals 3. To get rid of that, we're going to raise it to the 2. So we're squaring it. We got 3x. Those cancel out. Equals 9. Divide by 3. We got x equals 3. Okay, last one. I know this looks a little tricky. We have a radical on this side, an exponent on this side, but what really is this if we break it down? It's just the cube root of x plus 2. Well, how did we say we get rid of cube roots? We raise it to the 3. Is this going to cancel both of those out? Yeah, they're inverses. They cancel both those sides out. So it's actually, they're both raised to the same radical, or both have the same radical on them, so they cancel out, so it makes it nice and easy. And then we can solve for x. How do we solve for x? Well, we need to get x's on one side and numbers on the other. So we're going to have 2x plus 5 equals 2. Let's minus that 5. 2x equals negative 3. Divide by 2.